Hello and welcome to this presentation on understanding the Heisenberg effect of spatial interaction, a selection-induced error for spatially tracked input. This work was conducted with my colleagues Jan Guggenhammer, Marco Kombosch and Enrico Ruccio from Ulm University. So using this valve controller, you can see that whenever I press the trigger button, my controller gets displaced upwards. If we now imagine that I'm pointing at a target that I'm trying to select and I'm doing the trigger press again, my selection ray gets displaced and I end up outside of my target or selecting something totally different. We coined this the Heisenberg error. The difference between the selection vectors you can see here is what we call the Heisenberg magnitude, so the angular offset that we end up with. We were very interested in finding out how this Heisenberg effect impacts the selection performance. To this end, we conducted a within-subject user study with 16 participants, and we gave them two tasks. The first task is a standard pointing task, or what we call the ballistic task, where participants have to select disks that are shown at 8 meters in front of them. Additionally, to collect data on the hand jitter and the pure displacement of the selection when pressing the button, we collected so-called stationary data. So participants were asked to stay within the target after their ballistic click until the indicator turned green and then perform another click. We were also interested in how input parameters could influence the Heisenberg effect. To this end, we used body posture, so standing and sitting, arm posture, an extended arm and an applied arm, and the degrees of freedom, so using 6 degrees of freedom or 3 degrees of freedom. What we found is that the Heisenberg effect expressed a systematic upwards shift. We also found that the Heisenberg error was higher for smaller targets, but the Heisenberg magnitude reduced with the target size. We didn't find any significant difference for body posture. We did find a difference in the click duration for the arm posture. We also found, surprisingly, that 6 degrees of freedom led to a lower Heisenberg error than 3 degrees of freedom. So to sum it all up, we have found that there is a systematic directional shift, in our case upwards shift, with the Heisenberg effect. It does indeed impact selection precision and the performance, so the throughput. The posture of the arm and the body was largely irrelevant for the Heisenberg effect, but we did find that the degrees of freedom do impact the Heisenberg error, where 6 degrees of freedom led to a lower Heisenberg error. And that the Heisenberg effect can be compensated by different strategies, for example, a time shift, so going back to another selection position, using a lower trigger value, using larger target sizes, or just use a compensation function, which can happen in software.